Hello, am I audible, right?
Yes, sir.
Uh, okay. Good morning, all of you. So we will wait for five
Mhm.
more minutes so more student can join. After that, we will start.
Hello, good morning, everyone. So today we will take your doubt first. So if you have any
Good
doubt,
morning, sir.
yeah, good morning. So if you have any doubt, you can ask. কিছু বলছে নাই। No.
So if you have any doubts regarding week 4 slides activity question, practice question. You can just unmute yourself and go ahead.
Yeah, Neeraj, you have doubt? Any?
Sir, I have a doubt, but it is about week 3. Can I ask?
Yeah, sure.
Sir, I was trying the practice questions of SQL, but I'm having problem with question 4 and 5.
Okay, let me check.
Uh, in question 4 is consider the following SQL statement, create boards, right? That's one.
Sir, in question 4,
Consider the following SQL statement, create table boards. That's one.
uh, sir, write a SQL statement to find names of faculty who did not issue any book.
Subhendu, can you share the question?
Yeah, I'm set. I'm, mm, okay. Yeah, this question.
Yes, sir.
Okay. So, what did you what did you not understand?
Sir, I tried it, but I tried many variations, but I'm always getting an error. Incorrect select query.
Okay. So did you got the solution for practice assignment?
Sir, I got the solution. I mean, it is working on my system, but it is not being submitted. So I wanted to know if there is some mistake or
Okay. So let me share my screen. So let me share a schema diagram. I think.
Oh, okay, you faced problem in the submission in the portal, right?
yes, sir. I mean, I looked in the forum, but
Uh,
some people were able to submit, some were not. So I'm not sure if it is a mistake or
uh, have you follow the instruction? What are the instruction given? Remove the semicolon.
yes, sir.
Okay. Can you post that in the discourse? I think you have the right answer, right? No problem with the question.
Okay, sir.
Okay. It's just problem in the summation part. Is it that?
Yes, sir. Sir, also in question 5.
Yeah, only submission part, right?
Sir, I mean, I think I am right, but cannot be sure if there might be a problem with my logic.
On SQL statement, right?
Yes, sir.
Okay. So Bindu, can you show that?
So can you, tell how would you solve this problem? So that would tell us if our logic is correct.
Okay, sure. Let me share my whiteboard. So let me first open my PC again. So it will take time. Yeah, my screen is visible, right? Hello. 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 My screen is visible.
Yes, sir.
Yes, sir.
Okay, okay. So which database is LIS? Okay. Okay. So let me see questions. Mm, So see, you have to write a SQL statement to find the unique title which are issued to PGA student but not issued UG student. So basically, you have to find the book title you issued to the PG student but not issued to UG student. So, yeah. So see. So let me first see the table. So select start from book catalog. Yeah. So in this you'll got ISBN number, name of the title of the book, then publisher, then year. Okay. And then see that. Okay. Let's see that. Then let's see the table. Select start from members. So let's see the first. You will get member numbers, member class, member types, then member type UG and PG, then roll number, then ID. Okay. Then see. Okay. Then let's see the book copies. Book copies. Okay. So you will get ISBN number, then XSS number. Okay. Then let's see the table. Book issue. So you will get in the book issue table, you will get a member number and then accessor number and the date of joining. So you have to basically join the table. So yeah. So let's write the query. So you have to write select. You have to unique book, right? So you have to distinct. So distinct. Then title of the book. Then title. Then from. So you have to you will get from title of the book from book catalog table. Book catalog. LOG catalog. And you have to basically join the tables. So natural one, book copies, then you will get from which book issued, and basically so you will get from book issue tables. So then natural one, sorry, join book issue, book issue. Okay. Book issue. Then member type you will get PG or AG. You will get from members level. Natural one, book issue, natural one, natural one members. So you will get, you have to find PG students. So then where member type equal to PG. Okay. In this query, you will get unique book, that unique book title which are issued to the PG student in this query. So you have to find also which book issued to the PG student but not issued to the AG student. In this case, we'll use accept query. Accept. Okay, so you have to write seal there, then distinct title. Okay, let's copy the whole query. And you have to find not issued to the AG student. AG student. So let's run the query. So you will get the distinct book title which are issued to the PG student but not issued to the UG student. Programming C. Yeah, you got it.
Yes, sir.
Okay, thanks. Any doubt regarding week 4 activity question slide?
Sir, division operation of week 4.1. Can you explain
Okay.
it again?
Okay, Pradeep, do you want to take it?
Okay, 4.1 activity question.
Yes, sir, division operation.
Is it visible, right?
Yes, sir.
You not understand only the division operator.
Actually, sir, I got the logic how to derive at the answer, but the formula, it's a bit confusing. Can you explain that?
This one is. Suppose this is the P tables, and this is the Q tables. And so the attribute of the P tables is the AB, and the Q table is B. It is always, so P should be subset of Q should be subset of P. So the operation is like that. P, it equivalent to, first you need to, what it find, who issued all the things. Suppose there is like this, or 1 2, and here you can see that A and the B, and this is suppose A. And what will be your answer if you, without understanding that logic?
Sir, answer would be 1.
Yeah. So how will you get that? So first in the P, you select this attribute, whatever not in that attribute. Yeah, means that is given as, suppose this whole thing is right as the Z, and this is X, then this would be Z minus A. So, Z minus X, that is A, right? So we first cross product this. If we cross product this, what will we get? Yes. Then we get this a tables like A, B, in which what is 1 A and the 1A. We get this, right? Then we minus from this one. We minus this value. We minus this table, means this P tables. Are you able to follow me, right?
Sir, why 2B will not come in the cross product?
Okay. Yeah. Now this is fine. Yeah.
Okay, sir.
We take this attributes from the QB attributes, and we take only consider this, and we do the cross product, right? If we do the cross product, we will get that 1A and the 2A, right? After
Okay,
we
sir.
minus this value, means P value. If we minus this P value, we got it got minus, this value got minus.
Yes, sir.
Means in P, what is the value? 1 2B. Yeah, this value got minus, so that's why we write that A B P. So and what what will be the value of this? Means output of this value.
2A, 2B.
No, only 2B, only 2A, right? This
Only
value,
2A.
this 2A, right?
Yes, sir.
And from that, we only take this value, this Z value. Yeah,
Okay.
Z minus X value, right? And that is what? That is 2. Yeah, you get it. That is 2.
Yeah.
We disqualified this value, but what we need this one value. Yeah, so we minus from pi a, and this is the projection operator, right? We minus from this. This is the disqualified value, and this is the qualified value. So in what will be the value of this? This is value of 1, 2, and what will be the value of this? 2. So this, in this way, we get the qualified value, and after that's the final output will be this 1. You got the logic, right?
Yeah. Logic was clear, sir, but the formula, okay, got it. Thank you.
So can you please repeat it again? Like I got confused basically.
Okay. You got this step. Okay.
No, actually, sir, it will be good if you like repeat it from initial.
Okay.
Yeah.
Is it visible, right?
Yes, visible.
Okay. P divide. P division operator Q. What it should be? Q should be subset of P. Is it fine? So what does means the P, suppose there is a tables P, and the value of column will be A and B. Yeah. And Q should be subset of P. So there is only one column B. So suppose there is a value of 1 in Q, one value is there, that is 1, and the P value, suppose like that 1. Let to be 3A. Then what will be the value of P division operator Q?
It's 1 and 3.
Yeah, right. So answer 1 and 3. So how do we do that? So first we cross product this value. Suppose this two value, Z is the attribute of A and B, consists of A and B attribute, and the Q is only B attribute. So we cross product this value with this value.
But sir, you named it at P. Why did you like change it to Z?
No. In this, okay. Here.
Okay, you are forming a new relation.
No, not new relation. I takes the convention of the slide. Slide there is given the Z and the X, and this value is given at Z minus X. You remember the in slide it is
Yeah,
given
sir,
like.
but that was confusing for me. Like that's why I'm asking.
Yeah. I am telling that
Okay.
also. So you take simply. I tell you simply that you understand. Okay. So first we take this value, and we consider this value, and we cross product it, right?
Okay.
So we take this value. How do we project this value? Using the projection operator, and we take this from the p value, and from the q we take only the v value. Yeah, in this cross product, what will we get? There is a table.
We will get 1A, like 1A and 2A
2a,
and 3A.
3a. Okay.
Yeah.
If we minus this table from subtract this table from this, then what will we get?
We will subtract full table.
Yeah.
So then it will be 1A. It's, I think, 2. It's there
It
is
got
2A.
minus. Yeah.
Yeah, it got,
And
and
this
it
also get
also got
yeah.
Yeah. So 2A and 2B will be like there.
Then from what we get, this value only. The output of this is 2a, right?
Okay, okay. Yeah, 2A.
Then we select only this value. Yeah. From this whole table, means that is 2.
Okay.
And this is the disqualified value. Disqualified value. So what are the qualified value?
1 and 3.
1 and 3. So
Yeah.
we, and that is we take from, and here what is that?
So you just subtract it.
Yeah.
Okay.
In this way, we get the 1, 3. Yeah. Is it fine?
Yeah, fine.
Thank you.
Thank you, sir.
Sir, hello, sir.
Yeah.
Sir, can you please discuss the last 3 questions of practice assignment?
Which in which
Week 4, sir.
week 4?
Yes, sir.
Let me check.
Okay, sir.
Which question? Hello. Hello. Hello, am I audible, right?
Yes,
Yes,
sir.
sir. Yes, sir. Yes, sir.
Sir,
Yes, sir. Yes,
which
sir.
question? Last 3 questions.
Yes, sir. Last 3 questions. Yes, sir.
Okay.
Okay. In this 13 question, you not understand, right?
13 question and the previous 2 also.
Okay. In the what it is asked that what is the attribute of this A1? Yeah, A1.
Yes.
So what is your answer? What your understanding? How we build the relationship
So,
set?
sir, so first of all, I have to build the relationship within the bigger rectangular box.
Yeah.
Yeah, so that can be built in, that is a many-to-many relation. So that will require 3 tables.
Yeah.
And from that, I will be, from that 3 tables, I will be drawing another relation with a label D1.
Well, D1, why?
I mean, with the label, I have to name each of these entity set with D1, right?
Why that? I'm not understanding.
Because A1 is taking another variable,
Yeah,
another.
yeah. Here you can see the D1 is that descriptive attribute, right?
Yes, that descriptive attribute. Yes, sir.
Then why you write that as the attribute set? I'm not understanding.
Sir, actually, sir, I thought that in case of distributive attribute, when we convert that into table, we have to just add that attribute inside that table.
Yeah. No. In that's the relation. Here you can see the R1 set. How we write that R1 for that relation tables. So we takes the primary attribute from the E1. What is the right?
Yes. Yes, sir.
A1 table. So what is the attribute in the R1? A1, and after that E2, from E2 we take B1, and that C1 is there because that is the descriptive attribute in that relation. So
Okay.
in R1 there is 3 attribute: A1, B1, and the C1, right?
Yes, sir. Yes, sir.
Similar way, if you see the A1, so what will be the attribute?
E1 and D1.
E1 extra attribute is there, E1 and D1, right?
Yes.
And here you can see this is not required. C1 attribute is not at all required because this is the partial many-to-many relation that should maybe partial, right?
Sir, from where we are getting this E1, sir? E1 is the table name, no?
No, at a primary attribute, E1, a small E1 in the E3 you can see.
Actually, C1 is not taking because A1 and B1, which is create the relation of C1, but I'm taking both of these, right? So C1 is not required. Either I have to take the C1 or otherwise I have to take A1 and B1. Isn't it?
That is okay, but what I'm having trouble to understand is like in the bigger rectangle, we have created 3 tables. One table is for E1, and that will contain the attribute A1 and A2. Another table is for E2, and that will contain the attribute B1 and B2. And another table that will contain the attribute A1, B1, and C1. And from that attribute, from that table, I will take 2 attribute and form another table that is A1.
No, see here.
It is a relation. Yeah, please go ahead. Please go ahead.
Yeah, here you can see there is in the C1 is not required in the A1 relations set.
Yes,
Because
that is
you
okay.
already did that in the R1. You include that in the R1, right? So if we include A1 also, that is just redundant information for that. You include C1 as the R1 in R1 also and the A1 also. That is redundant, right? You store the similar information in.
Sir, could you please write the table that will be here? That would be easier for me to understand. I mean, not draw the table, entire table, but write at least in the set form. That
Yeah, is it visible, right?
yes, sir. Yes, sir.
This is E1 tables with attribute. Can you tell the attribute
Yes.
better?
A1 and A2.
A1 is
A1
primary key.
and A2. And there is a relation
R1.
R1.
E2.
A2. It has two entities, B1 and B2. B1 is the primary key.
B2.
And R1 has C1 as its.
And there is an abstraction.
Sir, if A1 can be connected with B1 and A1, then we can write that it can be connected with C1, only C1 and E1 and D1. That will be also okay, na?
Okay, let me draw after that you can arise.
Okay, sir.
Okay. So now you can ask. Yeah, go ahead.
Yes, sir. So I was asking that if entities of A1 will be E1, D1, B1, and A1, then we can remove A1 and
Okay.
B1, and instead of that, we can take C1.
You means entity means attribute, right?
Attribute. Sorry, sir. Yes, sir.
A1, what will be the attribute of that?
I'm telling C1, D1, and E1.
C1. C1,
D1 and
D1.
E1. E1.
You want to build the relationship between the this relation, right?
Yes, sir. Sir,
And
if we can take only A1 and B1, then we can change A1, B1 by taking only C1 also, na?
yeah, that is not possible in the ER diagram. That's why we use the aggregation, right? This is aggregation, right? In the ER diagram, it is not possible to build the relation in relation. We cannot connect to relation. Yeah, that's why we study the aggregation. Here can see this is an example of the aggregation, right? Am I clear, right?
Okay, sir.
Okay, now who is someone asked that question? Yeah, go ahead.
Yes, sir.
Yeah, go ahead.
Sir, so for the table E1, I will have A1 and attribute A1 and A2 with A1 as the primary key.
Yeah. Okay, for the A1, what? E1, right?
E1, yes, sir, yes, sir.
What will be your attribute?
A1 as primary key
Okay.
and A2.
Okay, A2,
E2,
okay.
A1 as A2, sorry, B1 as primary key and B2.
Okay.
R2 R1, sorry, R1.
R1,
A1 and B1, both
A1
as
and
composite key,
okay,
and C1.
okay, C1.
Yes, sir. So A1 will have
A1 will have okay,
A1, B1, C1, and D1.
A1, B1, C1, D1.
And D1.
Yeah, this is D1, right?
No, sir, E1.
E1. But here you can see one. So this is C only, right? But you can see there is C, you can take 2 times this value. Yeah, this is redundant, one kind of redundant, right? You take the similar value and maybe this value null or maybe possible, right? Or you maybe this value is repeated.
Okay.
These all are the primary key, right?
Yes, sir. Yes.
This is not
No,
a
no,
D1.
that not that one. E1 is primary.
Yeah,
Yes, sir.
yeah. And this, you take this value is a redundant. Suppose it is possible you can write this A2 also, but that is not required, right?
No.
Because we only takes the primary key for the relation to avoid that redundant, right?
Okay, okay. So, okay. Oh, okay.
Yes.
Understand, sir. Understand. Understood, sir.
I hope for that, how many table is required for this diagram?
For this whole diagram,
Yeah, yeah.
whole diagram, the number of the 4 and another one, sir, 5, I think.
And for this attribute are the A1, B1, E1, and D1, and all 3 are the primary key. And what is E3? What will
E3 with E1 as primary key and E2.
okay. Okay, so there is 5 table is required.
And we have to declare E1 as foreign key, no, sir?
Yeah, here you can see the E1 is the foreign key, it's the A1, right?
Okay, 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 sir. Yes, sir.
And what is your next question?
Sir, actually, it is like the question before that. 11 or 12, I think. Same practice assignment.
Okay, that's nice. It's like this.
Yes, sir, this one. So this one, what I understood is that E2 will have full participation inside E1.
And yeah, and E3 also.
E3 also, exactly, sir. E3
Yeah,
also.
yeah.
So,
Yeah.
I mean, I require 2 tables at first to draw, I mean, to represent this. Mainly 2 table and another table for both of them, right, sir?
Yeah. So first require E1 entity sets and the E3 entity set. And for
Yes, sir.
relationship R1 and R2, you can modify the E2 tables. You will get.
So, do we modify the E2 table or E1 table, because E2 is a weak entity set?
Now you have to modify the E2 table.
E2 tables, right?
Okay,
In
so
in E2 tables, you simply add this attribute of the primary key from E1 and the E3. Yeah. And it will build the relationship between that
A1
E1,
and B1, no, sir.
yeah, E1 and E3. It will build the relation using E2, we can build a relation. We simply add this attribute, primary attribute, right?
Okay. So inside E2, I have to insert this attribute A1 and B1. Then and C1 will be the differentiator inside E2. So
Yeah.
all three of them will form the primary key.
Yeah.
Okay, sir. Okay, understood, sir. Okay.
Then which
And
question?
one more doubt, sir. In case of role, that course ID and pre-course ID.
Yeah.
In that case, course ID will be the primary key of a table and pre-course ID will be the foreign key, right?
Yeah.
Okay, sir. Okay.
And the next question, I hope you got understand.
Yes, sir. Yes, sir. Next question. Yeah.
Okay.
Sir, same practice assignment, week 4, question number 6. Could you please make me understand how option number 3 is correct?
Okay, let me share my screen. Question number
6.
Okay.
Okay. Who is that? Aditi, right?
Yes, sir.
Okay. First, gamer ID is a primary attribute, right?
Yes, sir.
And the gamer name is
Name
the
is composite key.
composite attribute. In the composite attribute, we only write that this app name, m name, and the l name, right?
Okay, sir.
And in this curly braces email ID is a multi-valued attribute, right?
Yes, sir.
And this is simple attribute, and this is derived
Derived.
attribute, right? Yeah.
Yes, sir.
And okay, let's check the option one by. Okay. There is a glitch. When can you scroll up the oh. Yeah, here you can see the first option. The gamer ID is primary, right?
Yes, sir.
Gamer name, this will be not there because this is the composite attribute, I think.
Exactly.
So we can eliminate this option, right?
Yes, sir.
In the second option, we can see the gamer ID, app name, m name, l name, email ID. Email ID is multi-valued attribute.
Yes, sir.
So we simply remove this or eliminate this option also.
Okay, sir.
So we can check the.
And one more playtime.
Yeah. And the playtime is derived attribute. The derived attribute is not there in the database, right?
Okay, sir.
So we can check the third option, gamer ID, app name, m name, and the join time. This is first is fine. Second, gamer email. Okay, gamer ID and the email ID. This is the right option, right?
Yeah.
Okay, sir. I understood how it came. Basically, we don't have to take derived and multi-valued in the same
Yeah,
sequence.
we simply not take at all the play times, means this derived attribute in the database. We take the multi-valued attribute, but not with, we creates the another table for that.
Okay, understood. Sir, one more doubt. Could you please explain me the difference between bottom down and top up? Wait, top down and bottom up design approach.
Is it visible, right?
Yes, sir.
You understand that specialization, right?
Yes, sir.
And there is the generalization. And what is what? Specialization is?
On very specific.
Yeah, on the very specific. Suppose there is a
Instance.
person, or simply takes the employee. Is it okay? For the specialization, maybe he is a instructor or that's the secretary. So this is a specialization of it. Suppose that employee may be instructor or maybe secretary, right?
Yes, sir.
So first you identified in this, the specialization, you have to first identify what are the attribute of the employee. And after that employee there, if there is the value are the distinct, some value are distinct, a group, you can create the group, this instructor group and this secretary, right? So this approach is a top-down approach, right? First you identified the employee, after that you identified who are the instructor and who are the secretary, right? This is a top-down approach. Are you getting my point, right?
Okay, sir.
And there may be another case, right? You first suppose you have to design the database and you first identified this attribute, this entity set, and that is the instructor. Suppose, maybe possible, right? So you first identified that ID, name, salary. Now and rank. And for the secretary, you identify similar way, ID, name, salary. Wait, is it fine? So first you identified this two entity set, right? So in this, you can see that there is a similarity between some common column is there.
Yes, sir.
Common column means, I mean, attribute is there.
Attributes, yes, sir.
Yeah. Here you can see these attribute are same. These attribute are same. These attributes are same. So we can make another entity set which will contains this common value. Yeah. And
Yes, sir.
we keep this value for this instructor only, and this is just for sake of that ER design model, right? Only we do for that. So
Okay, sir.
suppose there is an entity instructor and secretary. and we create another tables, another entity set. Suppose that is the employee. An employee contain all that common attribute like ID, name, and salary. And this instructor only that additional attribute contain only the additional attribute. Yeah, is it fine? Here you can see for designing this this ER diagram, your approach is that bottom-up approach, right? First you identified these two attribute. After that you generalize that thing to
Yes,
another
sir.
entity set. This is
Yes,
the
sir.
bottom-up approach. And
Okay, sir. In top,
previously this is just opposite of
yes,
each
yes,
other.
sir. Yes, sir. Understood. So basically, in top-down approach, we go from general to specific. We specialize that, and in bottom-up approach, we go from specific to general. Yes.
You getting this is what you
Yes, sir.
understand.
Yes, sir.
What does it? Okay, let me tell you, this is a special disjoint specialization. This means that if the employee is an instructor, he cannot be a secretary. Yeah,
Okay, sir.
this is, and if any employee is a secretary, then he may not cannot be an
Or
instructor.
instructor.
Yeah, this is the symbol of the disjoint specialization. And another is there. Yeah, this is the overlapping specialization. In this, employee may be an instructor, maybe a secretary, or maybe both, right? In this way, we depict in the ER diagram.
Okay, sir. This was also my doubt. Thank you, sir.
Sir,
Any other?
what is the notation in ER diagram for this overlapping and complete? That for category, complete, overlapping, disjoint, and
Yeah.
can you please give that notation?
Yeah, it is visible, right?
Yes, sir.
Yeah, this is the disjoint specialization, right? This is the symbol of the disjoint.
Okay. Yes, sir.
Disjoint, and this is the symbol of that
Overlapping.
overlapping.
Yes, sir.
We denotes the overlapping with two hollow arrowhead. Yeah, in this way we depict in the ER diagrams, and this is the disjoint. Yeah, who asked that question? Is it clear, right?
Yes, sir.
What about
What is the
total
partial
partition?
and complete?
What?
Partial and complete. It's the same.
Okay, what does that means? Partial means the employee may be a person in the
That can be employees without, like, person without in any of the group.
whatever entity in that the person tables maybe belongs to the employee tables or the student tables. Yeah, maybe from the employee tables or the student tables. Every entity in the person tables should be belongs to any one of these employee tables or the student tables, or maybe from both. That is the total specialization, right?
Yeah.
Am I clear at that point? And if there is some value in the person entity that are not neither belongs to the employee tables or nor the student tables, maybe there are some
Yeah. But
some
is there any
entity.
special notation for that? That category?
No.
Okay.
I'm not aware of that. If I, then I
Okay.
will
That
let you
that
know.
was my question. Thank you, sir.
Okay. Any other doubt?
Sir, I have a question.
Yes, you.
Sir, can you draw a ER diagram? I'm telling you, there is a one-to-one relation.
Okay.
So can you draw? Yes.
Yeah. Yeah, tell me.
The E1 has two attributes, A and B, and E2 has two attributes, X and Y.
E1 has A1.
A and B.
Yeah.
And E2 has two attributes, X and Y.
And E2 has
Two attributes. So here the primary keys are A and X.
What is X and Y?
X and Y.
Yeah.
The primary keys are A and X.
Yeah.
The relation is one-to-one.
Yeah.
And the relation has one attribute. There is BG. So then how will write the table? That's my question.
Okay, Pradeep, can I take it?
Yeah, sure. Go ahead.
Could you stop there? Okay. So let me first draw that table. And relationship is one to many, right?
No, one-to-one.
Okay. So the attributes, like, okay. Okay. So in this case, there is two possible. Suppose the relation is R. So you can modify the E1 table also and the E table also, like this. E1, then primary key A1, sorry, A, then B, then tag, Then take primary key of E2 table. So X
X.
and the C, right? Let's take C also. And this will act as a foreign key. And E2 table will be X, then Y. And this will refers to X. This is a primary. But there is one possible or another possible also. So what is this? A1, then B, then modify E2 table. Take primary key of E1 table. So that first, the X, then Y. Then take primary key of E1 table, A, and then B. And this will act as a foreign reference to. I think you got it, right?
Yes. Okay, sir. Thank you.
That is
Okay.
Sir, one
Yeah,
question.
sir.
Sir, can you
Yeah.
show the screen back?
Oh, okay. Yeah.
last
Sir, in
one,
the
E2.
second option, E2, it should be C instead of
C.
B.
Oh, sorry.
Okay, okay.
Sorry. My mistake.
Sir, over here, X should be nullable, right, sir? In the first one, and A should be nullable in the second case. Am I right?
And which attribute are you talking about? This X.
Yes, sir.
No,
No.
not
Yeah,
nullable.
this.
Should it be nullable?
No, it is referring to the primary key. So how it will be null?
So
X is a primary key, right?
Yeah. So okay, it sometimes may be nullable. So let me give one example. I hope you understand.
Okay.
Suppose let's take an instructor. Its content
This is
attributes.
related to one graded assignment question. I think we cannot discuss this right now.
Oh, sorry. So, yeah, but you know, foreign key can be null or not. That thing I think I can discuss. I think. Then. So let's take one. Image X 2 Y. The ID is 3 Z. And let the student interval. Roll number. So let's take 10, 11 and the 12. And then I'm like Raj, Ram, the sum. Now 1 to 1 is like this, like Y and like this, like this. So let's modify the instructor term. So instructor ID, name, roll number, and the name. So see, one name is X. See, this ID does not relationship with any. So this should be null. So yeah, sometimes maybe null. Asim, you got it?
Yeah, but this instructor table, I mean, the roll number is, foreign key to the student.
Yeah, this is a foreign key of a student. So yeah. Sorry, this should name not be there. Sorry.
No, name is not the question. Question is the primary key. Whenever we are going to declare foreign key, so primary key doesn't allow null value, right? So if it is referred to the student, then how it will be getting null?
So see, this is referred to student, right? That is to, so see. Okay.
Because it is always checking the primary key, right?
Yeah.
Whatever the value
Yeah,
you
yeah.
are inserting.
Yeah. So see, foreign key can be null. So if you did not understand, let's try in PGRBD. I hope you will be understand.
Which one?
Let's try in PGRBD query. Let's make two table, and I hope you will be better to understand that knowledge allow or not. Should I try in PGRBD?
Yeah, I mean, I would like to clear all these things. I mean,
Okay, yeah. See. So stuff there. Screen. PGRBD. Okay. My screen is visible, right?
yeah.
Create.
Sir, just have a doubt. In case of primary key and foreign key, we are considering about the attribute, not the tuples. And
one thing I would like to tell. Yeah, go ahead.
And in this case, and you are referring the name which has an var character and comparing with a roll number which is an integer. And you are comparing to the tuples only. So it cannot be a foreign key. Foreign key has null value, multiple null values. But we should refer the name attribute to the student's name attribute, not the name attribute with the student's roll number attribute as a foreign key.
Not getting your point. Exactly. Can you repeat your word?
Actually, we have a one table over here in LIS that is member. It is targeting both faculty and student. So it's the same type.
Yeah. So see.
Yeah. This one.
So see, this is the foreign key reference to student. So this can be null also. I hope you got it, Asim, right?
I saw that.
Okay. So,
Yeah, it is a combination of these two keys in foreign key. That's what it is.
okay. Can you repeat? I did not got it.
Yeah, I mean roll number and ID both combined foreign key over here.
No. See, this ID is a foreign key referencing to this table,
faculty. Yeah.
Okay, only this, and this roll number is referencing to the student table. So sometimes, yeah, it can be null also. The foreign key can be null.
Yeah. I mean, I can see the either side values.
Yeah.
Thank you.
Someone asking some doubt about regarding that foreign key.
Hello. If you have any doubt, you can ask. Week 4 contents.
Sir, no doubt, just one clarification needed. So from the next week, we will be having the session for week 5.
Yeah.
Or
Yeah, this will be session for week 5.
Okay, one question. When I'm doing the natural join, it is between two tables, right? So
Yeah.
first one could be table and second one could be a subquery.
First one should be table and second one is see.
Subquery. Can I use it like that?
Yeah, Asim, that is possible, but name should be same. What you return from that subquery and that table's name, yeah, that should be same. Name means column name, right?
No, yeah. I actually I'm trying to write a query. Suppose select name from student, and it is I mean it is trying to
Natural join.
natural join with, I mean, need a subquery, I mean, sub part of the particular table's data, so that I can do it. I mean, directly.
Yeah, you can do that.
So that time syntax will be from student and natural joins, then directly query, or I have to put any names?
No, directly subquery, and after that subquery return will be, please put an alias of that, whatever the resultant set.
Yeah. I mean, that query, I mean, column name should be the same as the table
Yeah.
columns name. Yeah. That I do understand. Otherwise, it will not be. Yeah. Okay, thank you.
So we plan for the revision session on the Thursday or maybe Friday.
I mean,
from week 1 to week 4, please go through the every content. If you have any doubt regarding 1 to 4, week 1 to 4, you can ask on the revision session also.
Sir, and when will be the mock will be released for DBMS?
Okay.
I will discuss with teams and let you know.
Yeah, you can put that on the Discord, so then we will answer on.
Okay, sir.
Any question? Any question you have, you can ask if you have doubt.
Everyone is practicing the SQL query, right?
yes.
Yeah.
Sir, I have joined late, so I don't know whether I have a doubt. I don't know whether it's already covered. Can I still ask?
Yeah.
This is to do with the tuple relation calculus. The example used was in 4.2. The tutorial video 4.2 on aircrafts and flights, certified and employees. Okay, so we have to identify the flights that can be piloted by every pilot whose salary is more than 100,000. And so what we are doing is f dot flight number such that f belongs to flights. Now, this format is okay because I have to identify the flights when there is f dot flight number. But supposing I choose the other notation where I'm just choosing f such that flight number the whatever the condition in at the end I'm giving f dot flight number equal to something else dot flight number. Isn't that selecting all the tuples as in all the attributes and not just the flight number? Maybe I'm not very clear. I don't know. Can I put it down in the chat box?
Yeah, can you mention the 1 second, the slide number?
Q5.
Q5, there is a one number is that.
I'm sorry.
Q5, find the name and the salary of certified pilot working on the Boeing aircraft, right?
Right. So is this also not selecting the employee IDs? This is along with the names and salaries, whereas the question is saying that we need only names and salaries. That is my question.
Yeah. Okay, here you can see the above there is the natural join between the aircraft certified and the employee.
Right.
Yeah. For that, A1 is belong to the aircraft, right? And the C is belong to the certified. We
Correct.
joined these two in the first A dot AID equal to C dot AID, right?
Correct.
And the next is what we will do. The E dot EID equal to C dot EID. In this way, we joining this E means employee and the C means the certified. Yeah.
Correct.
And in this way, we join the three.
Right.
Three natural join. Yeah.
Right.
And here you can see we use the select clause using the A dot A name equal to Boeing. And we project using the P dot E name equal to E dot E name and the P dot salary equal to E dot salary, and the we returns that P in the way. P is that. Am I clear?
Anything which is extra from the joins, which I give as a condition in my TRC example, that gets projected. Would that be a correct assessment?
No, that is not the desired outputs, but we are looking for that. We only needs the name and the salary. You can also you can omit this part also. P dot E name equal to E dot E name. It will returns all the value, right? But that is not correct answer. Yeah. So you carefully go through that the whatever the query requires, it will not match with the what in the exam also. Please, if there is a returns the finds the name and the salary, then you only project that attribute. Is it fine? Otherwise, it will not match with the examiner output. So it will get the error.
Okay, so my question was, first I do all the joins like A dot AID equal to C dot AID and A dot A name equal to Boeing and E dot EID equal to C dot EID. And after that, whatever I want projected, in this case, it is names and salaries. I put an AND condition and do P dot E name equal to E dot E name and P dot salary equal to E dot salary. So whatever I want projected or whatever I want selected, that I have to specify after the joins have been done.
You can also see the in the relational algebra, you can, there is a explicitly mentions the pi, after that's the e name and the salary. You can omit that part also according to you, but that is not the correct output, right?
I got it. I got it, sir. Thank you so much.
Thank you.
Sir, I have a question from week 3 graded assignment week 3. Hello, sir. Hello, sir.
Yeah,
Yeah,
yes.
yeah.
So I have a question from graded assignment week 3. Question number 8, sir.
Okay, let me share. Yeah.
Yes, sir. So I am just saying you that what I understood, and please verify if that understood is correct
Okay.
or not.
First, let me read the question. If the employee, if the relation employee designation and employment 100 respectively, what is the maximum number of? Yeah, tell me.
Yes, sir. So what I understood is that so natural the employee table can have employee table has designation ID as foreign key, and designation has designation ID as primary key. So when I do natural join, it is obvious that the natural join will be based on this designation ID.
Yeah.
So natural join can have 100. I mean, natural join can have 100 repetition of same designation ID.
Natural. Yeah, possible.
Or it can have it can have 100 rows, but in any combination of this designation ID. Let's say
Yeah.
20 D002 30 D001 like that.
Yeah, it can
Yeah.
possible.
So that's why when I do the natural join, it will pull up all 100 of these rows. I mean,
Yes.
that can happen in maximum case.
Okay. See.
So if you takes the employee side, how many is that? 100 unique or the duplicate value?
Yes, sir. 100 table.
Yeah, 100 tables that all are the unique, right?
Yes. All are unique.
And the what employee, and after that's the designation, and the designation part. So tell me your answer.
So actually, I wrote the answer 6 because I thought that when I am doing the natural join, uh, when I am doing the natural join, so the common attribute will get selected, and the within the common attributes, the common entries will be fetched and displayed. So I thought that only 6 rows will be displayed, but when I saw the answer, I thought that okay, I was wrong. So what I understood is employee can have 100 combination of designation ID.
Okay, let me give one example. I think you can understand. Okay. So let me start. Suppose the employee table, the ID and the
Yes.
designation ID.
Yes.
Okay. So ID is 1, 2, 3, 4, like this. Okay. And the designation ID is 1. All are the 1. Sorry, 10. I think that will be better.
T1, yes, sir. Okay. Okay.
Okay. And the designation table, suppose designation ID and the name.
Yes. We have only one designation ID, that is 10.
Let's say okay. If you do the next one, so what will happen?
This designation ID will be taken from employee ID, and designation ID from designation table will be taken.
Okay, then
Then,
what will happen?
so we will get all of this, no sir? 1, 2, 3,
Yeah,
4.
you will get all of this. Yeah, you will get all of this.
That is, it will act like a Cartesian product.
No Cartesian. This it matches with the both the means it see designation ID is matches with the 10. So it will
be clear, Subinder, if you adds then one attribute 12 equal to B, 12 and B instead is designate.
Okay.
Just add in the tables.
Okay.
The 12 and B. After the second tuple. Yeah, 12. Now, how many attribute is there if we do the natural join? How many tuples are there?
Sir, I will have 4, sir.
Yeah, 4. If we add the 13 and C, then also that's the.
Yes, sir. Then
yeah,
also.
If there is the 100 employee with the same designation ID, then it will be 100, right? Whatever
Yes.
the with respect to the resignation table or the relation. So I hope you get it.
Yes, sir. Yes.
In this table, how many tuple you will get?
I will get 5, sir.
Yeah, I think you got it.
Yes.
Okay, thanks.
Thank you.
Any questions? You can ask me.
Yes, sir. One question. So from week 4, practice assignment, question number 7.
Okay. Pradeep, do you want to take it?
Yes. Let me check.
Sir, actually, I understood why option A and C is correct, but I didn't get how DRC expression came. It is quite confusing to understand. Only that last option in which domain relational calculus is used. Please explain me.
Okay. I will explain after that. If you not get, please go through what the user explains the previous live session. Yeah.
Okay, sir. Okay, yes, sir.
So here you can see the option.
Sir, you are not audible.
Yeah.
Okay.
Let me show. Is it visible, right?
Yes, sir.
So what is the first rule in the DRC is that first we write this way in the there exist.
Yes, sir.
Yeah. After that we see this is we taken from the doctor relation or the tables, we take this output DID, D names, and the orthopedic means only those tuples which in the specialization or the specialist in who are the orthopedic, right?
Yes, sir.
Yeah, only select these three uh, attribute, and so from the operation roster we takes the D name and the D. Can you tell what is
We
the
take
that?
doc ID and patient num.
Yeah, uh, yeah. After that, this is the cost. I think and that is
Yes,
cost.
sir. Operation cost.
Operation cost. We only take this value from from the operation roster, and we only select here directly. We select this value orthopedic, right? And the here whose cost is greater than 100. Yeah, 1,000, right? You can write this also outside like this, like DS, right here the DS, and so you can add the DS equal to yeah. Now is it okay, right?
Yes, sir.
Or this is the simple way to write how to write the DRC, yeah, domain relational calculus.
Okay, sir. I understood. Actually, I was confused with this DIRP and RC thing. I understood. Yes, sir. Thank you, sir.
Okay, if you have any question, you can ask.
Yeah, for natural joint, as many as table I can join it over here. I mean, is there any limitation?
In natural join,
Yeah, I mean, as many as tables. Suppose I need to join 4, 5 tables. There will be any issue?
no, you can join.
So one more thing, one suggestion is that whenever I'm submitting any SQL query, like practice assignment and graded assignment, I need to save this file in the query, I mean query.sql or any name I can give it. There will be an issue.
In the name there is no issue, but you have to keep in the dot SQL.
Yeah, .sql I will keep it, but file name will be different, right? Because
Yeah.
it will be easy for me to save the files in my, so that I can see it later.
Yeah, no problem. Any other doubt?
Sir, what if we did it without .sql?
Then the algorithm, backend algorithm will not read your code. What is the SQL statement will not run. It is designed in that. Okay. Is it fine? Yeah. Who is? Whatever instruction given in the portals, please follow that. Am I audible, right?
Yes, sir,
sir,
you
thank
are
you.
audible.
If any problems or any problem faced in the submission of the queries, then please put in the Discord script.
Okay, sir, thank you.
Okay. Thank you.
We will wait 2-4 minutes. So if you have any question, you can ask. Otherwise, we can find out.
Yes. Thank you. Thank you, everyone.
Yeah, thank you, and have a nice day.
You too.
Yeah, every
Thank you, Asif. Have a nice day.
Thank you, sir.